So the last section of this topic looks at chemical tests. First of all, the chemical tests for water, and then also flame tests, which identify metal ions present within a salt or within a solution. So it's important that we know the chemical test for water because chemists often encounter colourless liquids in their experimental work. And so to determine whether a given colourless liquid contains water, we use a test substance called anhydrous copper sulfate. So it's really important that you learn that name exactly as it is written. So the anhydrous part means that it doesn't contain any water of crystallization. So the word anhydrous means essentially without water. So it's really important that you know that and that you include it in your name. And it's copper 2 sulfate. It's important that this test substance doesn't have any water to start with, so that when we add water to it, we know that it's the water that we've added rather than the water that was already within the substance to start with. It's really important that you know that anhydrous copper sulfate is a white powder. It's a white powder and it doesn't contain any water initially. But when we add water to it, the colour changes from white to blue. And that's a really important colour change to learn. So when water is added, the colour changes from white to blue. The blue solid that forms is what we call hydrated copper sulfate. So it's not anhydrous anymore. It doesn't not contain water. It now does contain water. We've added water to it. And what actually happens is the water molecules bond to the copper sulfate. And it forms this nice blue crystalline solid, which does contain water of crystallization, and that's why we see this colour change from white to blue. And believe it or not, this has been a 6-mark question before. It has taken the format of a chemist has 3 different colourless liquids. How would he test to see which contains water? And what you had to discuss was that he would test each of the liquids using anhydrous copper sulfate. There was 1 mark for the word anhydrous, 2nd mark for copper sulfate. And again, if you were asked in an exam, what do you use to test for water, you would get 2 marks for that answer. 1 mark for writing anhydrous, 2nd mark for writing copper 2 sulfate. So make sure you know that name really, really well. And then in terms of that 6-mark question, so it was 2 marks for the anhydrous copper sulfate, 2 marks for saying that the one that contained water would turn it from white to blue, and then 2 marks for kind of the general practical advice of adding each of the liquids to anhydrous copper sulfate. So it's really, really important that you know this test substance and what you would see that colour change that identifies water is white to blue, and I'll show you a video of that in a second. But just moving on down the page, just to write an equation for that. Anhydrous copper sulfate is copper sulfate that contains no water. So we can get the formula of it just by doing our swap and drop. So copper is Cu, and you can see from the brackets that the valency is 2. Sulfate you get from the back of the periodic table is SO4, also with a valency of 2. You can see those valencies are going to cancel out. So my formula for copper sulfate is just CuSO4 plus water, and actually it reacts with 5 molecules of water. So I'm going to write plus 5H2O. And then how we show that the copper sulfate is now hydrated is we simply write copper sulfate, CuSO4, and then we do a big dot, and then write our 5H2O there. And that dot simply represents that those waters are now bonded to the copper sulfate molecule. So 5 water molecules are bonded to the copper sulfate molecule. We'll look at that in a bit more detail next year, what that water of crystallization actually means. But technically speaking, you could be asked to write an equation for this. I would doubt it. It's probably very unlikely, but that is the equation that represents this process. And what you've got down below is the method for doing this. So to test a liquid or a solution for the presence of water, you add a few drops of the liquid or solution to be tested to anhydrous copper sulfate on a watch glass. And if water is present, the white powder will change to blue hydrated copper sulfate. In other words, you'll see a colour change from white to blue. So again, this is similar to our test for hydrogen or our test for carbon dioxide. First thing is, what do you do And second thing is you comment on what do you observe then if water is present. So make sure you know the test substance for this, anhydrous copper sulfate, you know the colour change, white to blue, and what you would actually do. So put a bit of anhydrous copper sulfate on a watch glass, add a few drops of the liquid or solution to be tested, and if it's water then it will change from white to blue. And I'm going to show you a video of me carrying this out now. So you can see here in this video I've got my white anhydrous copper sulfate on the watch glass. The watch glass is literally just a piece of glass with just a slight curve in it. The anhydrous copper sulfate is on that watch glass. It is a white powder. We've got it on a heat proof mat because this reaction actually gives out a lot of heat, which we'll look at again next year. And you can see I've got a beaker of water, and I'm about to add that water to the watch glass. So let's have a look now. Okay, so you can see I'm adding the water to the anhydrous copper sulfate, and it is changing from white to blue. So as soon as the water's in contact with the anhydrous copper sulfate, the water molecules actually bond to the copper sulfate, and that produces hydrated copper sulfate, and it is blue. And then finally, we have got our flame tests, which are used to identify metal ions within a salt or within a solution. So it's used to identify metal ions. With this, there's two really important things that you need to learn. First of all, the thing you need to learn is a method. This can be a 3 or 4 mark question, and it has come up a few times since the specification changed. This is new to the specification since it changed a few years ago, so make sure you learn this method. And again, I'm going to show you a video of me doing this, but just to run you through it. What you want to use is a piece of nichrome wire with a loop at the end. You want to dip the loop into concentrated hydrochloric acid. Now that word concentrated hydrochloric acid is really important. This was a multiple choice question at one stage where it asked you to circle the right answer of what you dipped your nichrome wire into it, and it just had dilute hydrochloric acid, sulfuric acid, concentrated hydrochloric acid. So it's really important that you know that it's concentrated hydrochloric acid that you need to use. And if you were asked to recount this whole method, if you didn't write that word concentrated, you wouldn't get the mark. So you dip the wire into concentrated hydrochloric acid. That has two functions. It wets the loop so that when you put it into your salt, that the salt actually sticks to the nichrome wire, but also it cleans the wire. So if you're using the same wire for multiple tests, then it'll clean it in between. So when the tip is wet, dip it into a sample of your metal salt, so that there's enough salt around to coat the tip of your nichrome wire. Then what you want to do is put it into the blue Bunsen flame. So using the blue flame, place the nichrome wire into the flame on the Bunsen burner and record the colour of the flame. If you use the yellow flame, again I'll show you this in video, it'll just interfere with the colour that you produce of the flame. So it's really important that you use the blue flame. Again, if you don't record this in your method, then you won't get the mark. You need to say using the blue flame. Place the nichrome wire into the flame of the Bunsen burner and record the colour of the flame. And the colour of the flame will actually tell you what metal ion is present within your salt, or you can also use this on a solution of the salt. So for example, a copper sulfate solution instead of just the copper sulfate crystals. And you can see here your diagram of the test. And the second thing you need to know with this flame test, so it's all on this one page, is the flame colour of 5 metal ions. So there's 5 metal ions that you need to know the colour of the flame. So when we carry out this flame test, if your salt contains sodium ions, then the colour of the flame they produce is yellow. Now they will accept yellow, or they will also accept orange, but they don't accept yellow-orange or yellow/orange. So what I would say is just go with one, but also if they were to give you the colour orange in an exam, then you still need to be able to recognise that it contains sodium ions. So if they said flame test was carried out and an orange flame was produced, you would need to know that that is sodium. So it's worth maybe noting that in your notes anyway, but stick with one or the other. So if you were asked what colour would sodium ions produce in a flame test, you choose yellow or orange. Don't write yellow-orange. And potassium ions then, if they are present in a salt, you will get a lilac flame. Lilac is like a light purple. Think about when potassium is reacting with water. Remember that nice lilac flame that we got with that reaction. It's the same colour here when you are burning a salt that contains potassium ions. If the salt contains lithium ions, you get this lovely crimson flame. So it's a lovely colour to look out for. It's this really deep red, kind of slight pink hint to it as well. It's a really, really lovely flame. So lithium ions will produce a crimson colour. With calcium ions, you will get a brick red flame, which is kind of a mixture of red and orange, that in between reddy orangey colour, but you have to quote it as brick red. And then with copper ions, if they are present in your salt, you'll get this lovely blue-green flame. And it's blue dash green rather than blue slash green. If you wrote blue slash green like this, you would not get a mark, because what that means is that it's either blue or it's green. I can't decide which. No, the blue dash green means that it's somewhere in between blue and green. It's that bluey greeny colour. Now, I do not kid you when I say that your colours must be quoted exactly as they appear in this table. See, are really fussy about their colours. So, for example, if you wrote just red for calcium, you wouldn't get the mark. It must be brick red and brick dash red. Again, with lithium, crimson is a form of red, but if you just wrote red, you wouldn't get the mark. Or if potassium, you wrote purple, you wouldn't get the mark. It's lilac. Okay, so learn those colours exactly as they are. Put them on a post-it, write them around your room. Make sure you can quote those colours exactly as they are. Now, in the next video, I am going to carry out a flame test on a number of different salts labelled A to E. And what I want you to do is, in the table on the next page, which I'll show you now, in this table, if you could record the flame colour from the video, and then the metal ion present. I'll run you through it at the end, but try and record this as you go. So through the video, record the flame colour and record the metal ion present. So you can write the name of the ion or the formula of the ion. I will probably write both when we come through this at the end. So the experiment we're going to do now is our flame test practical, and as we've already discussed, flame tests can be used to identify the metal ion present in a salt. So we're going to do this experiment as an investigation. You can see here I have 5 different salts labelled A to E, and what you can see is that they're all white powders. So just by looking at them, I cannot tell what is in them or what metal ion they contain, and that's where I'm going to use my flame test. So I've already talked about the method, but what we're going to do now is see that in action. So here in my watch glass, I have some concentrated hydrochloric acid. This is my nichrome wire. Hopefully you can see it. It's a very thin piece of a metal alloy wire with a loop at the end of it where we're going to dip into our sample of salt. Got a Bunsen burner and my salts here to test. So as we've already discussed, the first step in this method is to take your nichrome wire, make a loop at the end, and dip the loop into concentrated hydrochloric acid. That has 2 purposes. First of all, to clean the wire in case there was any sample on it before. We can actually use the same wire for the different samples as long as we clean in between. So it cleans the wire, but also it wets the end of the wire so that when we dip it into our sample, some of the salt actually sticks to the end of the wire because it is wet. Okay, I'm just going to do that again to try and get a little bit more of sample A. So I'm going to start with sample A, and then we're going to put it into our Bunsen flame. So I want to put it in my Bunsen burner now, but there's something I've got to remember to say. I don't use this yellow flame because, as you can see right now, it already has a colour, it's yellow. I wouldn't be able to see the colour of my flame just as clearly. So I turn it so that it's on the blue flame. And as you can see now, you can barely see the colour of that. And so when I put my sample of salt in, I'll get the clearest colour of the flame that the salt is producing as opposed to the Bunsen burner. So my sample on the end of the nichrome wire, I'm putting it in my blue Bunsen flame. You must refer to the fact that it's the blue Bunsen flame, otherwise you would lose a mark. So I'm going to put that in. Okay, you got a glimpse of the colour at the start. This is actually one of your more difficult salts to see the colour in. So let me just put a little bit more on my nichrome wire. Okay, and what hopefully you can see there And it's quite hard to see with this one. Well, hopefully you got glimpses of a lilac flame there. Let me try that one more time to see if we can get a better flame. There we go. So hopefully you can see that really kind of pale purple, pale pink colour that we refer to as lilac. Remember, C are really fussy about their colours. So that lilac flame, and then go to your previous page and see what a lilac flame represents. It represents the metal potassium. So I can tell that sample A contains potassium ions by the fact I have a lilac flame. So in your results table, could you record that A gives us a lilac flame colour and it contains potassium ions. Okay, I'm going to now move on to sample B. Again, take my nichrome wire, dip it in the concentrated hydrochloric acid to clean it and to wet it. Dip it into your sample and then place it in your blue Bunsen flame. Okay, this time I've got an orangey reddy flame. Hopefully you can see that red tinge to it as well. There we go, there's a bit more of the red tinge. Let me do that again for you to see. So you've got a kind of orangey red flame. I'm thinking about the sea colours, thinking what that most closely represents. So you've got an orangey red flame there. There's the nice red part of it there. Orange red flame, what could I refer to that as? This is your brick red flame. Okay, this is your brick red flame. Look at it closely. And then you need to ask yourself, what metal ion does that represent? Well, the brick red flame shows me that calcium ions are present. There's your red tinge there. So that orangey red colour we refer to as brick red, and that represents that there's calcium ions present. So again, in your table, could you put that the flame colour for B is brick red, and that shows us there's calcium ions present. Let's move on to C now. Again, dip our nichrome wire into the concentrated hydrochloric acid, dip it into our sample of C. I'm just going to do that again. I'm just not sure I've got an awful lot there. Okay, dip it into our sample and then let's put it in the blue Bunsen flame. Okay, so you can see it's a similar colour here, but hopefully you can see this is a more intense red, kind of more of a pinky red as well. This is what we refer to as our crimson flame. Hopefully you can see that nice and clearly. Put a little bit more of that sample on so you can get a good glimpse of that colour. There's a little bit more there. Okay, so there's your intense red colour, which we refer to as crimson. Check your table. What does crimson represent? Well, crimson shows us that there are lithium ions present in this sample. So if I hold it just at the edge, hopefully you can see that lovely crimson colour. That's one of my favourites. Okay, so that crimson colour shows us that there's lithium ions present. So again, in your table of results, can you write that C gives us a crimson flame, and that shows us lithium ions are present. Okay, let's move on to D now. Again, dip my nichrome wire in concentrated hydrochloric acid. I'm going to dip it into sample D and place it in my blue Bunsen flame. Okay. So a glimpse of the colour there, that didn't last too long. Let's do a wee bit more. Okay, and there we go. There's our nice blue-green flame, really stands out, it's quite different. I'll try and get a wee bit more for you there. That must all be burnt off, we'll try that again. So this is our nice blue-green flame. What metal ion does that represent? Well, it represents copper. There's your nice blue-green flame there. It's like a turquoisey colour, but again, you can't write down turquoise, you've got to write down the sea colour, which is blue-green or green-blue. Don't use a slash, because blue/green would mean you couldn't decide whether it's blue or green and you were just going to write down both. It's either blue or green. No, it's an in-between colour, an in-between of blue and green. So we represent it, we refer to it as blue dash green or green dash blue. Either's fine, but you must refer to both colours with a dash in between. So there's your nice blue-green colour. That's another one of my favourites. And that shows us that there's copper ions present. So for D, record your flame colour as blue dash green. And that shows us that there's copper ions present. Okay, let's move on to our final sample now of E. So again, we'll dip our nichrome wire into the concentrated hydrochloric acid, dip it into sample E, and let's put it on our blue flame. Okay, and this time you should see a very clear cut colour of either orange or yellow. You can refer to it as either, but not orange dash yellow in this case, not orange slash yellow. You must pick one and just write it down. So if you think that's closer to orange, go with orange. If you think it's closer to yellow, go with yellow. You would get a mark for saying either. It doesn't matter, but you must refer to this as orange or yellow. Both would get you a mark. Check your table. What metal ion does that represent? Well, an orange or a yellow flame shows us that sodium ions are present. So this salt contains sodium ions. So by doing this simple flame test, dipping your nichrome wire in concentrated hydrochloric acid, then dipping it into your sample and putting it in a blue Bunsen flame, recording the colour will tell us what metal ion is present in our salt. So let me run through those flame colours quickly just to check that you recorded the correct colour and the correct corresponding metal ion. So salt A, the flame colour was lilac, and that shows us that potassium ions are present. They have the formula K+, and that just corresponds to the group number that they're in. So potassium is in group 1, so it forms ions with a charge of +1. B gave a brick red flame, which shows us that there are calcium ions present. Calcium is in group 2, so it will form an ion with a charge of 2+, so it's Ca2+. Salt C gave us a crimson flame, which shows us that there are lithium ions present, that's Li+. Salt D gave us that blue-green flame, or you can refer to it as green dash blue, and that shows us that there are copper ions present, Cu2+. And then salt E gave us a yellow or orange, remember you can refer to it as either, but not both, and that shows us that there are sodium ions present, which have the formula Na+. And finally, to wrap up this topic, I'd like you to complete section 3 of the Unit 1.9 chemical analysis questions, which covers chemical tests, the test for water, and these flame tests.